Hello everyone. Today we will talk about how we can use LangGraph with LangChain to build a simple two-turn chatbot. Now let's get started. As you can see, I have a lot of my initial imports. Let me clear everything and start from scratch. I have installed all these packages using UV, and for the sake of this exercise, we will be using GPT-5 Mini from the GPT-5 family that was just released recently. Now, anytime an OpenAI LLM needs to be queried, you need to pass in your OpenAI API key, which you will set up using their website. Now, I have exported the OpenAI API key as part of my environment variable, and the command that I've used to do it is here, as you can see. Now, LangChain provides us with a simple method of calling these LLMs. We need not use OpenAI's chat interface. So it is encapsulated through this wrapper, through this object called chat OpenAI, where you specify the model, which you can see here is the GPT-5 Mini, and then we specify a max token. I have set it to 4096, but in practice, especially for a chatbot, depending on your usage, you might want something small. Now, 4,000 tokens is quite massive. It could be up to 10 pages. So take it with a grain of salt. Now, let's initialize this. Now that we have our LLM, let's see how we can go about invoking it. Now, it is fairly simple to invoke the LLM. All you need to do is just pass in a string here, like LLM, and call it through the dot notation of invoking it. So it will be llm.invoke and you pass in the string. Now, the interesting thing is the result that you get back. The result is not a simple string that you get back. You get back something called a AI message. Now, this AI message has multiple parameters, multiple variables, and the only item that we are interested in at this point is the content, because this would be the result of the LLM. So to the question of, or rather to the query of hello there, we are getting back a response of hello, how can I help you today? And this is from GPT-5 Mini. Now there are other tokens here that we would go into more details at a later stage, but at this point it is enough if we just stick to content. Now the interesting thing is, this is not the native output from OpenAI. However, it has been wrapped by LangChain into something called a AI message. So this is one of the three types of messages that LangChain provides. The other types are system message, which contains your system prompt, the human message, which contains the user's query, followed by AI message. Now, when you see, as you can see here, when we run type, we get the type as it belonging to an AI message. And you can use the dot notation to get the content. Hello, how can I help you today? Which is the same as what we have here. And the type is AI. Now, for those of you who have used the OpenAI's chat interface or chat completions SDK and endpoints, you would be accustomed to passing in the system messages, the human messages, and the AI response through a list of such messages. Now, all this has been encapsulated by LangChain, so it is something that we as users, as developers, need not explicitly code out again. Now, let's create a simple human message, and we will see how we can use it in our chatbot. Now, to create a message, whether it's a human message, a system message, or even an AI message, all that is needed is that you need to pass in the content here. Right, before I forget, LangChain provides more than three types of messages, and we also have a tool message, but for the sake of this exercise, we will be just focusing on these three types of messages. Right, coming back. So to create any sort of message, all that needs to be done is you need to pass in the respective string for content. Mind you, it always has to be a string, followed by uh, calling it through the human message, or rather by initializing it through a human message. Similarly, for a system message, this is how we would go about it by initializing this object. To invoke it, all it needs is just by calling it through the dot notation of invoke, followed by passing in a list of these messages. Now let us run this. We have the human message, we have the system message, the AI response. Now it takes some time, and let's see what the response is. Hello, how can I help you today? If you meant the programming example, I can show hello world in many languages. Tell me which ones you want. This is an interesting message. Now, since we're talking about multiple turn chatbot, we would want to respond to this. And in this case, I have already written up my response. And that is something as straightforward as I'm learning about building agents and just started with LangGraph. Give me your response in 2 lines. So this would be our next message, which we would then add to the list of messages that we have and pass it to the LLM to get its response. Again, 3 seconds. And our response this time is great. LangGraph lets you visually design and wire LLMs, tools, and memory to build modular agents. Follow the quick start, create a simple agent, and ask GPT-5 Mini for step-by-step code or troubleshooting. Now, this is how a simple, not very efficient chatbot can be built using LangChain and LangChain alone. It is sufficient. It is not necessary that LangGraph be used to build a chatbot. I'm sure that any of you can cleverly decide how you will get human input and add it to this list of messages that we have so that the user has the appearance of talking to a chatbot. But here we are today so that we can learn about LangGraph and build a chatbot so that we can learn more about LangGraph. Now, let's look into see how we can actually use LangGraph to do the same thing that we did previously. In LangGraph, all agents are nothing but state graphs. Now, what is a state graph? A state graph is nothing but a graph where each node is a transformation on a particular state and an edge decides what is the flow of information in the entire graph. Now we can see that we just want a basic conversation state which only has messages to begin with. Now we can see here that it is nothing but a simple typed dictionary that we have imported here. Now what is a typed dictionary? Now in simple terms, it is nothing but a dictionary which has a little bit of type hinting to begin with. So let's start and run this. My bad. Let's start from the beginning. Now the nice thing is Jupyter allows you to run things up to the selected cell. So that way, anytime you make a mistake, it is quite easy to recover and run things right up to the cell where you were previously. Now, invoking this LLM takes some time. Right, there we have it. Now, to initialize the basic conversation state, all you need to do is just pass in the object that you want, or rather that you're initializing, and call it just like any constructor. As you can see, we have the state object, we have messages. Similarly, if you don't create anything, it will be an empty dictionary. I wonder what happens if you create it with something that it doesn't, that it should not have. Our object is basic form state. Count is equal to 1. I guess it works. To not do this, it is quite bad programming to initialize it this way. Okay, so we have the basic conversation state, which is nothing but a list of messages, which ideally should have a list of messages. These are simple hints at this point. So we create it. Now, we will skip this helper function. I will explain why we need this. Once we have gone through the respective nodes, we have the user input node, and the aim of the user input node is nothing but to get input from the user. and we are using the simple Python construct of input to get user input, and we are returning this specific dictionary where we have the messages, and we're passing in a list of one element, that is the human message, which contains the input that the human has provided. Now, we are using a type dictionary to inform LangGraph as to what are the respective components within the state. So that is where it comes into picture. Now, there is a caveat here which I will demonstrate before talking about it. And let's look at the LLM response. Again, it is very straightforward. We invoke it with the state. Now, this state should ideally have the entire conversation history that was there up until this point. We print the response and we just return the AI message that is responded. Now, those of you who are quite astute, or those of you who are watching closely, you might notice that there is potential for something to go wrong. It is not a runtime error, but as you will see that there is something that doesn't go right. Now, let's look at the helper function. This helper function is there just to demonstrate and to show you what is the state, or rather what are the values present within the state that we get as input to each of the nodes. So let's initialize this. Let's run the cell, the user input. Let's get the LLM response. And now let's come to building the graph. Now, like I mentioned earlier, LangGraph builds agents through something called a state graph. Now we initialize the basic graph builder. And since we want a two-turn conversation, we are adding the same function twice, but each time with a different name. LangGraph throws an error if you repeat the same function name and the same function. Or rather, it throws you an error anytime you repeat the same function name. So we add a node by just calling dot add node. We pass in a string here. This is the name of the function of the node, followed by a function. As you can see, there is no need for any decorators at this point. So we are adding the first user input. We get the LLM response. We get the next user input, and then we get the last LLM response. Now, we have just added the nodes here. So all LangGraph knows at this point is there are 4 nodes. 2 of them get user inputs and 2 of them get LLM responses. But how do we connect them? How does information flow between them? And that is where edges come into the picture. Any LangGraph agent that is using the Graph API, it should start from the special initialization point called start. Now, in essence, start is nothing but a string, which is 2 underscores followed by start followed by 2 underscores. This is a LangGraph construct, something that LangGraph expects. So I would not advise any of you to play with this. So initially, we go from start to user input 1, that is get user input. We are adding an edge from start to user input. Similarly, we go from user input 1 to LLM call 1. Then we go from LLM call 1 to user input 2. That is, we first get a user input, we get input from the user, we make a call to the LLM, get a response, print it, get the user input again. This is the second input here. And then from the second user input, we make a last call to the LLM where again it will be printed. So let's run this and we compile the graph. Basically it tells LangGraph that this entire thing is one simple graph. And we have a very unique thing where we can visualize and see how the graph is. One suggestion is that when you're building more and more complex graphs and agents, have a simple rudimentary idea of how this graph is going to look like. You can use multiple tools, or like me, you can use pen and paper. And once you have that, Then you can go about constructing and designing and building your agent. For now, let's look at the graph. Yes, perfect. So you can see we start with start. We get the first user input. Again, this is the name that we're passing. Right. One nice thing about Jupyter Lab is that you can split the same notebook and view it twice. So I right click on Basic Chatbot and click on New View for Notebook, and that pops up the same notebook with the same state on the other side. So this makes it easy when you are referencing cells that existed earlier. Now, we can see here we have user input 1 that corresponds to get user input. That is this node here, this function, where we're getting the input from the user, followed by the first LLM call, the second user input, followed by the last LLM call. I'll keep the functions up here so that it becomes easy to reference. All right, let's run the graph now. So again, just like we spoke about earlier, we have a system message. This is basically me instructing the LLM to adopt a particular persona. And I'm calling it Jarvis because Iron Man inspired me when I wanted to get into AI and machine learning way back in 2011. Right, this is a Jupyter Lab function. Do not worry, everything is running as expected. Now we have a simple system message here. Let's initialize our initial state for the agent. That is the basic conversation state. We pass in basic system message, one single item, one single element in the list to the messages property of this state. And let's inspect the state. Yes, as we can see, we have messages, we have a list, and we only have one item there. Now, invoking a graph is very similar to invoking the LLM, like how we had discussed earlier. We just call .invoke and the content needs to be passed here. Just like how you can pass in a string or a list of messages. Similarly, here we will just be passing in the state, the initial state. Again, let's have the function so it becomes easy to debug and understand. Let's run this. So it started and we are in user input node. And the first thing that happens is it prints user input node, which we are seeing here. The next step is print all messages, and we are passing all the messages in the state that we have received at this point. And as we expect, we can see only the system message. So it is the first element, it's the first item in the list. It is a system message, and we can see the output here. Or rather, we can see the content of that message here. And let's see, it's a simple question. Hello, my name is Shri. And we immediately go to the LLM node. Why did I jump? Okay. Yes, we immediately go to the LLM node. Now, this LLM node, again, what we are seeing here is it prints LLM node input. We see that here, and we're printing the entire state here. This is the state that is the input to this specific node here. We have gotten the input here, and we're passing that state to LLM call 1. And we're printing all the items there. But there is a problem. We see this one here, and it just has one item in it, that is 0, as in that is the index of the element in the list. What is the type of the message? Message.type, which is pointing to human, followed by the message content. which in this case is, hello, my name is Shri. But where did this go? Where did the system message go? Something that we had passed, something that was the first input to the graph. Now, this is an interesting thing from LangGraph. It just so happens that anytime anything is returned, that overrides what is present in the basic state. So anytime anything is returned from the node, that overrides what is present in the state. Now, there are a few interesting ways of overcoming this, and there are ways in which that need not be handled explicitly, but LangGraph will take care of it, but we will get to that in a while. Now, let us continue. So the LLM node only has one input, that is from the human, and that is, hello, my name is Shri. The response that is happening here that it gets, and its input is again only the previous messages that it has, which unfortunately is just one input, and we are printing the response that it provides, that is here, where GPT-5 is telling us that it is nice to meet, and if you have specific pronouns, let me know. Okay, now the next thing is user node input. Now this is the input to this specific node, and we can see we have user node input. Now the funny thing again is that we don't have any of the previous messages. There is no system message, there's no human message. We only have the AI response, or rather the AI message that has gone in. Actually, nice to meet you. How can I help you today? If you prefer pronouns, please let me know. Not sure why GPT-5 is asking for that. Now, let me ask it, what is your name? And we are in the LLM call 2. And you can see here that it is saying that it is ChatGPT and not Jarvis. Now, the big question is, how can we go about having any sort of intelligent conversation when it does not, when this system, when this simple chatbot that we have built does not remember the previous conversation or the previous step in the conversation? It is not possible. So that is why we would need to be a bit clever in how we handle the state. And the final thing before we leave this particular graph is that the output from this graph is the output from the final step here. And let's see that. It is just one step here. Now, let's look at a working chatbot, where this one has memory and it remembers what was spoken about previously. So let's start. Again, let's use the same constructs that we have. Type dictionary with one property, that is messages, which has a type of a list. Let's initialize that. Now, this user input node is different. How is it different? We get the input, we do put it into a human message, but we keep track of the state explicitly. I'm creating a new object here, new messages, which is nothing but a reference or a copy of your state messages. It is still a reference at this point. We append the human message to it, and then we return the new messages. So what happened, what is different is the output of this user input 1 contains the input that it has gotten, and that is being sent to the next node. This is a subtle difference, but it is a big departure from the way the previous user input was written, where it just sends out the human message that it got and it forgets the previous state. Now, similarly, for the LLM response, again, we create a copy and we add the AI response, which is different, where we are just returning the AI response from the previous iteration of the same graph. So when this uh, node was called, initially it was returning the same state, but now we are keeping a copy of whatever state existed before. We're appending the latest AI response and sending that entire state to the next node. Let us run this and we shall see the difference. Again, the method of adding the nodes is the same. We are adding the edges in the same way. Now I'm explicitly adding an end state. It need not be done. It is good practice. It is legible to add it. Let's compile the graph and let us visualize it. Yes, and this looks the same as what we had earlier. Now, using this as reference, let us start running the chatbot. We have the system message. Again, you are a helpful chatbot named Jarvis. We create the initial chatbot state, which has the system message. Let's inspect this. Yes, we have this. Let us invoke the chatbot. Yes, you are a helpful chatbot named Jarvis. Now let's try something different. Hello, my name is Sri and I am a programmer. And now you see the difference here. The LLM. Okay, the LLM node has more than one message state. So the initial message state during the first node, that is the user input node, has only one message. That is the system message. Everything works as expected up to this point. Now, we get the user input where I introduce myself with my name and what I do, and that is then passed to the LLM node, which is here, LLM call 1. We have one system message that was passed in here. That's the one, followed by the human input. Hello, my name is Sri and I'm a programmer. And the response from the LLM, the response from this node here is what we have here. Surprisingly, GPT-5 Mini is quite verbose. I did not face this problem, or it did not face this peculiarity when I was building this with GPT-4 4.1 Mini, in fact. Okay, now we have the LLM call 1, that is this specific node, and then that is the information, the state goes from that node to the next user input, that is the next node. And when we get to user node input, that is this method, that node sees three messages in the state: the system message, the human message, followed by the AI message again. Now let us ask it, what is your name? Now this is slightly cheating because we have the AI response which says that it is Jarvis, but it has the memory, and you can see we are asking the question, what is your name? And the response that we get is, I'm Jarvis, your assistant. How can I help you today, Shri? And hence we have the output. Now, do you remember how I mentioned that the output of the invoke method is a final output from the last node in the graph? When we look at it here, we have chatbot output where we have the messages and we have all the messages here. when compared to the previous graph, which only had one message. Now let's manually call and look at what these messages are. The first one is the system message. The second one is the user input. The third one is the response from the LLM, which goes on to here. The next is the user response, the user message, followed by the final response from the LLM. Now, this still requires us to manually handle the state, to handle the input and the output from the state. Now, this is cumbersome when you have to deal with multiple state objects, multiple state properties, and especially if it gets more and more complex, handling it is quite tedious. So that's why LangGraph gives us a very good tool that takes care of that for us. It is something called a reducer function. And the reducer function in this case that we will be utilizing is nothing but add messages. As you can see, we imported from LangGraph. We are using the annotated type int, where we are telling it that it is of a type list, but it has the reducer function, or the metadata that is being used as a reducer function is add messages. So what this does is when we are returning a message, in this case that we have with the chatbot response from the working agent, we are returning the entire state by copying it and appending it explicitly. However, in this case, we need not do that. We need not even put it in the form of a list. We can just return the message, because what this does is that this implicitly appends it to this property. So we as developers need not manually go in and write code to copy the state and pass the state forward and make modifications to that state. It is updated as it is. So let's run this. Oh my god. Let's run this. Then again, we follow the same paradigm where we print what node it is. We print all the messages, we get the input, and we simply return it. Similarly in the LLM response. Now again, when we build the chatbot, it is the same as the previous steps. Let's start again. You are a helpful chatbot named Jarvis. Let's get the advanced state. We initialize it with the system message, and now let us invoke it. You are a helpful chatbot named Jarvis. Hello, my name is Sri. Tell me more about programming, but be concise and limit your response to just 2 sentences. Do not introduce yourself or me. And you can see here that Jupyter it's a late day, is cutting short the response that we're printing on screen, but we can scroll to view it. The initial LLM that we have, the initial graph, is in this form. The user input gets just the system message. We pass in our specific input, and the first node here, LLM call 1, gets two messages, the system message followed by the human message. Now, we are initializing this with these with the advanced methods here. So we are only passing back one message. We are not handling the state internally explicitly. Right. In order to access this properties within the state, you can access it through the dictionary notation. Oh, I did not print the graph. No matter, we can do it quickly. So this is why I like having a split view of the notebook. I can quickly copy paste it. Ah, yes. We are still waiting on input here, hence we are unable to do this. No matter, we are using the same node, the same structure as the previous graph. Right. So we have the LLM node. Control is in the LLM node where it is passed two messages, the system message followed by the human message, and we get the AI response. Programming is the practice of writing instructions in a programming language, so on and so forth. Now the good thing is we are not repeating our name, or it is not repeating the name of Jarvis. And now we are back in user input node. So let me ask it a question to test its memory. What is your name? Now, in this case, up until this point, the input to user node has just been the system prompt, the human query, and the AI response. In the first instance, the very first graph that we see here, it said that its response is, I am ChatGPT, an AI assistant. And in this case, we were just returning one, the last message that we have generated or that the LLM has generated, but we are wrapping it up in a list here. In this case, we are not doing that. We are just returning the final message in that node. So from all looks and purposes, it should throw us through an error, but because we have added the reducer function here, this step that we did in the next working chatbot of handling the state ourselves is taken care. So the response that you see here is, my name is Jarvis. And this, my friends, is how you can build a very simple chatbot, a simple two-turn chatbot at least. Now, where did we visualize it? Yes, is where we can visualize a simple two-turn chatbot. Now, to have a working chatbot, there are a few things that are necessary that we will go over in the next video.